Okay, welcome back. So this is the second part of our lesson on distance and speed on the Earth's surface. And what we're going to do now is work out how far somewhere might be if it's on a different longitude but the same latitude. So if you see those words on a parallel of latitude, that means the latitude is the same. So you can see I've done this gorgeous drawing for you here, and each parallel of latitude goes horizontally around the Earth's surface. Just a reminder that that's what that means. So it means they're on the same latitude, and this little formula here is the exact one I gave you back at the start of last lesson. So for every degree difference in longitude, we need to multiply by that little formula there. So let's have a go at that now. So find the distance along the parallel of latitude between Bowen, which is at 20 degrees south, 148 degrees east, and Port Hedland, which is at 20 degrees south, 119 degrees east. So first thing you should do is write down the formula. Distance for 1 degree of longitude is, and it's approximate, notice, 111.2 cos theta kilometers. So first thing you should do is substitute what the latitude amount is instead of theta. So we can see our latitude is the same here, it's 20 degrees south. So put that 20 degrees in instead of theta, which will give us 111.2 cos 20 degrees kilometers. Then, just like we did before, we need to calculate the difference, but this time it's a difference in longitude. So that is going to be 148 degrees minus 119 degrees, so the difference between the two is 29. Now I don't need to add them together because they're in the same direction. They're on the same side of the prime meridian. So just like it was, if the latitude was different, north and south, we would need to add them together. Exactly the same thing works for longitude. Except it would be either side of the prime meridian. But because they're the same direction, we just subtract. So now we've got enough to actually work it out. So the distance for 29 degrees difference of longitude is 29 degrees times 111.2 cos 20 degrees kilometers. So put all of that into your calculator, and that's going to tell us that they're approximately 3,030 kilometers apart. Now, something I want to point out. If you are asked for the shortest distance between two places, sometimes it might mean turning around and going the other way around the Earth's surface. So remember that Earth is a globe, so you can go in either direction to get to the same point. So to find that, you would just take the full 360, because 360 degrees is if we go all the way around the Earth's surface and take away the difference in longitude. So if your difference is greater than 180, more than 180 degrees, go the other way if possible. So that would be how you find the shortest distance. So just think about it. If we wanted to fly from here to New Zealand, going from here to New Zealand is definitely the quickest way. If we turned around and we flew the other way around the Earth's surface, and we, instead of going from the east coast, or where we are, Brisbane is, straight to New Zealand, which is about 3.5, 4 hours, instead, if we turned around and we flew across Australia, out the west coast past Perth, and we kept going around and around and around the world, we'd still end up in New Zealand, but it would take a lot longer. So keep in mind that sometimes turning around and flying the opposite direction is the quickest way, and sometimes that's what it's asking for. So that's if it's asking for shortest distance, keep that in mind. All right, so we're going to continue with the questions from this chapter. Exercise 6.2, all the questions 1 to 7 need to be done. Any problems, please let me know.